All right, so let's move on with the next part of complex numbers here. We have, just give it a little. So the next thing with the complex numbers, all right, is what's called standard form. All right, standard form. I've seen this before with quadratics. So standard form is this: a plus b times I. Okay, so that's standard form. A plus b times I. So now what is A? All right, A is a real number. Okay, so A is just some real number. All right, that's why you got to know what real numbers are. So essentially, real numbers are anything except imaginary numbers. Any number you've ever dealt with, except for just until we just started doing I, is a real number. B, all right, B is a real number. Okay, so B is the same thing. B is also a real number. So A and B are real numbers. Okay. Now, what we have right here, this in terms of this is this collectively is a complex number. Let's actually rewrite it again rather than do it there. Let's go down here a little bit, rewrite that. So collectively, A plus BI, right? This whole thing is a complex number. Now keep in mind, right? Every single number is complex. You can write any number ever as a complex number. Okay, so A plus BI is a complex number. Okay, and it's the standard form of a complex number. Now, in particular, this right here, A, this is called the real part of the complex number. And then this right here, right, the BI, that's the imaginary part of the complex number. Okay, so you have a real part, A, and the BI is your imaginary part. Collectively, that's your standard form of a complex number. Okay, so 2 plus 3i, right? 2 plus 3, right there. That, okay, is a complex number. Okay, the real part, is 2. Okay, the imaginary part, 3i. Okay, so that's it. So we have our complex number standard form, the real part, and the imaginary part. Okay, we said every number can be written as a complex number. So let's take, all right, some examples of writing in standard form. Okay, so for instance, the number here. Let's go like this. It's a real number. Okay, so here's our real number. Okay, 2. Okay, now 2 is a real number, but it is also a complex number. Keep in mind, that's our highest classification numbers. And in standard form, we'd have what? 2. There's no imaginary part, so we could write the complex number here, 2, as 2 plus 0i. Right, so that would be written in complex form. All right, with the real part and the imaginary part. Right, so in this case, we only have a real part, 2. There's no imaginary part, but we can represent that by writing 0i. If I had something like -3/4, okay, -3/4 I can write as the real part, -3/4 plus, again, 0i. All right. So there's the real and then written as a complex number. Okay. Now, we might also have complex numbers that have both a real and imaginary part. For instance, like we just had on the previous page, something like 2 plus 3i. Okay. So our real part 2, imaginary part 3i. Let's go back up here a second. Notice here, this is no imaginary part, which when you look at this, you got to realize that right there is what? This, and both of these, right, are really what? They're real numbers, just written in complex form. So both those are real numbers because there's no imaginary part. Now this one, 3i, there is an imaginary part to this complex number, which means that this number here, right, the 2 plus 3i, this is an imaginary number. And it's also always complex, right? That's the highest up on that list. So it's a complex number and it's an imaginary number, okay? 2 plus 3i. And then we have something where we have no real part, so something like 0 plus 4i, okay? So if we had something like 0 plus 4i, and there's no real part, okay? So we might just see this same one as 4i, right? Because they're the same, right? This is just written in kind of the standard form. Since there's no real part, okay, this number here, yeah, it's complex number. Every single number is complex. Right? It's a complex number. It is an imaginary number. But since there's no real part, we say this is a pure imaginary number. Okay. So when there's no real part, you have a pure imaginary number. If there's no imaginary part, you have a real number. Okay. So that's your complex numbers in standard form. Nothing really, I don't think, too complicated there. It's new. I give you that. Absolutely, it is new. Okay. But a little bit of attention to detail here and you'll be fine. Okay. So moving on to, here we have, we're going to go with adding and subtracting complex numbers. Okay, adding and subtracting complex numbers. Now, before we get into adding and subtracting complex numbers, okay, let's look at this. Now, don't write this part down, okay? Don't write this down. If I said take 2 plus 3x plus 4 plus 2x, right? Well, what would you do here? You would just read across and go, oh, that's 2 plus 4, right? You add the real numbers there. You had 2 and 4. Right? 2 plus 4 is 6. And then you have positive 3x plus positive 2x plus 5x. Right? So I'd have 6 plus 5x would be my result. If I had something like this, 3 minus 2x minus 2 plus 4x, like that, okay? And well, I would just read across and say 3 minus 2, right? 3 minus 2 is 1. And then I would say negative 2x minus 4x. What's negative 2x minus 4 more x? Would be minus 6x, right? So algebraically, there's adding and subtracting, okay? That's not new, okay? No one have any problem doing that. And I went over that there because adding and subtracting complex numbers isn't really that much different at all, okay? At all, right? So suppose I had, here, let's just do a couple examples, right? 2 plus 3i plus 5 plus 4i. Right, what's that equal? It's really not any different in the sense that you add the real parts, 2 and 5, and then in this case, you add the imaginary parts, positive 3i and positive 4i, okay? So you just kind of read across and say, all right, let's start with the real part, 2 plus 5. 2 plus 5 is 7. And then you read across 3 plus I, or sorry, positive 3i plus 4i. 3i plus 4i is 7i. So plus 7i. Okay. And that is the result. We had here this imaginary number plus this imaginary number is equal to, in this case, that imaginary number. Okay. There's adding those two imaginary numbers. Let's take number 2. Let's go with 3 plus 4i minus 2 minus 3i. Make sure you pay attention to your signs here. Now, one thing which I see, and I have trouble understanding, there's this subtraction sign here, which means we're subtracting these two numbers. We're subtracting 2 minus 3i from 3 plus 4i. Don't do this kind of thing where you distribute 3 times 2 and 4i times 3i and 4i times 2, and right? This isn't multiplication, so don't multiply. You are subtracting. Just read across. 3 minus 2. What's 3 minus 2? 1. And now 4i minus negative 3i. Well, minus negative is a plus, so 4 plus 3i is plus 7i. And now we have subtraction. That's all there is to it. So nothing to overcomplicate there. Okay? So we had imaginary number minus imaginary number is imaginary. Now something that pops up, questions is, well, if I add or subtract imaginary numbers, do I always get also imaginary numbers? So let's look at this one. Let's look at 2 plus 5i plus 3 minus 5i. So what am I adding? I'm taking an imaginary number. And I'm adding an imaginary number. What am I going to get? Well, let's look. In this case, I'm going to have 2 plus 3, 5. And then I have positive 5i plus negative 5i. Well, that's going to be 0, in which case I have in this example 5, which is a real number. Okay, so is an imaginary number plus an imaginary number always imaginary like it was in the first group? No. Maybe you get a real number. Maybe you get an imaginary number. So in this case, when you add or subtract imaginary numbers, you may or may not get an imaginary number. Maybe you get a real number. Maybe you get an imaginary number. Okay. So add and subtract. And then in the end, we do want to add and subtract and simplify. Okay. So whether we're adding and subtracting, okay, well, right, adding and subtracting, we want to simplify. Okay, so make sure we're simplifying these in the end. So let's go with something like, one more example here I think would be sufficient. Let's go with something like 2 times 4 plus I minus 3 times 2 minus 2i plus 4. Okay, so add and subtract, and we, in the end, we want to write in standard form. So when we're adding, subtracting, and multiplying later on, we want to write in standard form. That, keep in mind, that's a plus b times I. So now here I put a 2 out front. Well, just like if this was 4 plus x, what do we do with this 2? We take the 2 and we distribute it. Okay, that's the same. So 2 times 4, 8. So this 8 plus 2 times I, 2i. There's that. Now, what about over here? Now we're distributing a negative 3, right? Distributing a negative 3. In which case, negative 3 times 2 minus 6. Negative 3 times a negative 2 plus 6i, right? Make sure we distribute our signs correctly. And then last we have this plus 4 in the end. And now we look and we combine like terms. We have 8 minus 6 is 2 plus 4 is 6. So there's the real part, 6. And then the imaginary part, 2i plus 6i is plus 8i. There we go. Done. Okay. So there in this case, we had some multiples of this imaginary number. All right. 4 plus I times 2. We had the 2 minus 2i times a negative 3. All right. And then combine your like terms, write it in standard form. Okay. Now, this is the same answer, 8i plus 6, okay? But it's not in standard form, so get used to it. Write it in standard form. The real number part first, plus or minus, in this case, now the imaginary number part, right? So make sure we do that. Take care of that, okay? So that's all there is to adding and subtracting complex numbers, okay? I'm going to stop on this one, okay? So watch this over, all right? Pay attention to examples there, notes, okay? Don't overcomplicate this. I'm breaking this down as much as I can for you because this is pretty new. All right. It can be a little confusing, so I want to break it into parts. All right. So watch this over. Let me know if you need any help with anything, you don't understand anything. Okay.